Hi everyone, this is Mrs. Trig now, and this is page 6 of the Semester 2 exam review for Algebra 1B. This video will cover questions 26 through 29. Okay, 26 is our last exponential growth problem that we've got to get through. Let's see if I can get it on there. And this is talking about population growth in Canada. It starts out with Canada's population in 2010 was measured at 34,238,000 people. And over the past few years, the population is growing at a rate of 1.3%. So again, this is just regular exponential growth, which is y equals ab to the x. Now, they're asking us to use the letters p and t instead of y and x. It doesn't bother me if you stick with y and x, but I'll go ahead and use the p and the t. So p is going to go in instead of y because that represents the total population. A is my starting amount, which is that 34,238,000. Now let's be careful with our B. It says that we're growing at a rate of 1.3%. If you watched the previous video, or maybe it was two previous videos, we talked about how with exponential growth, you want to focus on what percentage you're keeping. Well, remember that if you're adding 1.3%, that means you're keeping 100% of what you already have and then adding an additional 1.3. So with that 1.3, you've got to add 100% to it. You've got to do 100 plus 1.3. If you're worried that you'll mess up the decimal places, go ahead and do that in your calculator. And it would be 101.3%, which is what you really want to use. And then remember that you also have to move that decimal point. So for your B value, you'll have to put in 1.013. And then it'll be to the power of t, which is just your number of years. So that would be your final model for letter A. 34,238,000 times 1.013 to the power of t. And be careful with that growth factor. If you miss putting that 1 out in front of there, if you miss moving the decimal point, your answers for B and C are going to be pretty far off. Okay, so be very careful with that. Okay, question B wants us to find the population in the year 2022. Well, remember our starting value was in the year 2010. So what we really want to do is figure out how many years have passed since 2010. And from 2010 to 2022 would be 12 years. If you weren't sure about that, you could do 2022 minus 2010 in your calculator. So that means I'm going to do this formula again. 34,238,000 times 1.013 to the power of 12 for 12 years. And that can go straight into your calculator. I'm just typing away over here. And I come up with, just make sure I get my commas in the right spot. So my population is 39,978,061 people. And it's 61.5, so I would probably round to 62, but I would probably take your answer either way. Just remember these are people, so we wouldn't want to leave it as a decimal. Okay, I would take either 61 or 62 on the end there. And again, let's look at that as compared to that original starting value. That seems like a pretty reasonable growth in 12 years to go from 34 million to 39 million. If you got something that was either smaller than that or something that was ridiculously large, I would maybe double check your model, make sure that you did your growth factor correctly. Okay. Question C is the same thing, except it wants you to go back in time to 1992. So if we started in 2010 and we're going back to 1992, let's see, that's really going to be going 18 years back. So T would equal negative 18. And again, if you weren't sure about that, do 1992 minus 2010, and that should give you negative 18. Just want to double check my own mental math there. Yep, that's correct. Okay, so let's put negative 18 in place of t, just like I did before. So my population is going to be 34,238,000 times 1.013 to the power of negative 18. And let me just type that away real quick. Okay, and I end up with 27,135,534. And again, I would say that looks like a pretty reasonable number compared to the other numbers I've gotten in this problem. So again, a good way to kind of check yourself and make sure you're getting the right answer. And again, make sure you don't leave decimals on there because this is people. We don't have parts of people. Okay, on to chapter 10. Chapter 10 is trigonometry, so this is a little more recent in your memory. Okay, question 27 requires a little bit of critical thinking here. It says, which angle has the smallest sine? Well, remember that sine is the opposite side over the hypotenuse. Okay, so, and you've got to be using a right triangle to do trig. So like when I look at angle 1, to do the sine, the opposite side is going to be this one over here. Okay, and the hypotenuse is going to be this one here. When I do angle 2, my opposite side is going to be the same. Okay, they're all going to have the same opposite side because they're all using kind of the same right triangle here. But now, if I'm looking at angle 2, this is my hypotenuse. So I'm going to call this H1, I'm going to call this H2. And then angle 3, if I was to do the sine, again, it would be the opposite side here. Over this side is my hypotenuse. So I would call this H3. Okay, so notice that angle 1, all the tops are going to be the same. I guess, let's see how I want to write this out. Angle 1 is O over H1. Angle 2 is O over H2. And angle 3 is O over H3. So all of the tops of the fractions are the same. It's really the bottoms of the fractions that are changing. And we want to look for the smallest sign. Well, think about how fractions work. When fractions get smaller, what happens to the denominator? And if you're not sure about that, think about like 1/2 and 1/10. What's bigger, 1/2 or 1/10? Hopefully you realize that 1/2 is bigger than 1/10 because you're only splitting into 2 pieces, whereas with 1/10, you're splitting into 10 pieces. So really with fractions, as the denominator gets bigger, the fraction itself gets smaller. So when I want to look for which one of these is the smallest, I want to look for the biggest denominator. Okay, the smallest fraction is going to have the biggest denominator. Well, let's look at H1, H2, and H3. Which one of those is the biggest? Hopefully you can see that it would be H1. Okay, is the longest of those 3. So the smallest fraction is going to be this one right here for angle 1. Opposite over hypotenuse number 1. Okay. By the way, I wouldn't have been able to ask you that question if the opposite sides weren't all the same, because then you would have too many things changing at one time and you wouldn't have been able to compare. But since the denominators were the only thing changing, you should have been okay. Okay, 28, exact values. These are just those values we took a quiz over. So if you wanted to double check your own, you could check on your unit circle. I'll go ahead and fill them in really quick, but these were ones that you should have known off the top of your head, at least in the recent past. And we learned that hand trick, so if you need a review on that, let me know in class and I'd be happy to show that to you. And we also talked about some different ways to remember the unit circle, and that would help you fill these in too. Sine of 30 is 1/2. Cosine of 30 is square root of 3 over 2. Tangent of 30 is square root of 3 over 3. Sine of 45 is square root of 2 over 2. Cosine of 45 is square root of 2 over 2. Tangent of 45 is just 1. Sine of 60 is square root of 3 over 2. Cosine of 60 is 1 over 2. And tangent of 60 is just square root of 3. So again, those are just those values off the unit circle. And yes, you will have to know those for the exam. Okay, question 29. First thing I notice here when I look at question 29 is that this is not a right triangle. If it's not a right triangle, I'm going to have to use either law of sines or law of cosines. And I'd love to use law of sines if at all possible. This side AB is my x. The problem is I'm not going to be able to use law of sines unless I have the angle that's across from it. So I need to know this angle. But luckily I can find it because in a triangle, if I know these two angles, I can always find the third one by subtracting from 180. So to get this angle, and this is sort of just before I even start the problem, I'm going to need to do this. To get that angle, I want to do 180 minus the 70 and minus the 48. Okay, so let's see, that gives me 62. So angle C is 62 degrees. Now I can pair these two up together with the law of sines. And remember, when you're doing law of sines, you need to do the sine of the angle, not sine of the side. So this will look like this. Sine of 62 over x equals, and then we need to pair it up with either of the other pairs. And I could actually use either one. I could do the 48 and the 15, or I could do the 70 and the 19. Makes absolutely no difference to your answer. I'll just go ahead and use the 48 and the 15. And again, when I pair these up, I want the sine of the angle. So I would do sine of 48 over 15. Now I'm going to cross multiply and divide. And really all I would do here is I would do sine of 62 times 15. And then after I get that answer, I'll divide by the sine of 48. Okay. So in my calculator, I would type, let me show you here, sine of 62, make sure you close off those parentheses, times 15, and then divide by, and I would do sine of 48. That would give me a final answer of 17.8. And that is correct. And again, I kind of checked these other sides, 15 and 19 for my other two sides, so I think 17.8 is pretty reasonable. Okay, and that's the length of side AB. Okay, that's it for this video. We'll pick up with question number 30 in the next one.